I was preparing this talk about big data and outreach and development, and then I was also hearing Bonita talk about gender and big data, and I couldn't help but remember our friend and colleague Carolina. I think she was working at the intersection of all of these topics, and I think we miss her sorely once again. My name is Neeraj Ramanujam. I work at the Indian Institute of Astrophysics in Bangalore, in India, and I think some of you might know me from my earlier stint in Surrey as well. I'm going to talk about EDO. EDO in the AFAS lingo stands for Education Development and Outreach. In the age of big data, bringing the universe into classrooms. I don't have to belabor the point of big data and how it's become the next big thing and how astronomy has changed forever and so on. You all know it better than I do. But then, what has not been talked about that much is the impact of big data on education and outreach. And in this context, by education, I mean school education for my talk. I know the previous speakers had focused more on college education. I'll be focusing more on school education. This will not be about any specific project. This will be more of a general pedagogical talk, and I'll raise a few points which I hope will lead to some discussions. Now, big data and EDO traditionally has been assumed to be in the form of citizen science, right? We all know Galaxy Zoo. You have a few of the examples on the right side of this image, and the citizen science become very, very popular across the world, including in many BRICS countries, of course. And the advantages of citizen science is that the main motivation for coming up with citizen science is to get the general public and students to aid professional researchers. It relies on human pattern recognition. It also provides a sense of personal engagement by which people kind of feel attached to something they discovered or they marked or they found or they recognized and so on. And of course, the most famous success story is Hanny's Forward, which is a very strange kind of galaxy, I think, in emission, which Hanny found in Netherlands from the Galaxy Zoo data, right? But then this is not the be-all and end-all of big data. And I think in going forward, one needs to kind of look at other paradigms of how you can use big data in education and outreach and development. And I'd like to quote the 2015 inclusive astronomy recommendation, where it says that asks the community to make data, software, and publications open access, etc., etc. This is aimed more at the professional astronomers. And I was kind of thinking of how one could kind of modify this to also democratize access to data for the purposes of outreach and education, right? And to me, the answer is not very clear. So I'm kind of thinking through it in this talk. So let's look at some classic examples. I think my favorite example is the SDSS Voyages program. It's built on the SDSS dataset. It has fantastic tools of plotting, visualization, lesson plans, etc. It has graded exercises depending on your age. It's customized. A teacher can go and customize a lesson plan based on what it has already. It's aligned with the American curriculum and is available in English and Spanish. And of course, the SDSS led to one of the most successful citizen science projects, namely the Galaxy Zoo, which started the whole Zooniverse project. I think people my age or older would remember the first citizen science project came up in '99, which is SETI at Home, and I think the big one after that was Galaxy Zoo. So this for me is a classic example of using big data for school education in a way which has built its own ecosystem of data, tools, interpretation, lesson plans, guidance for teachers, guidance for students, etc., into one single location. Right. The other examples, of course, also, for example, there are people who have made small telescope time available for schools to kind of make small images for fun or to do maybe something a little bit bigger than that. And two of the prominent ones I know of the Las Cumbres Observatory, of course. Las Cumbres is mainly for for research, but then they also have a global scale partner where they allocate some time on some telescopes for school students. And of course, then the school's observatory is another big project which uses the Liverpool telescope, which I think is supposed to be one of the largest amateur telescopes available for free for the public to use online. Right? There are a lot of attempts being put into data visualization for students. Of course, SDSS Voyages is one example. Some of you might know Salsa J. Astrometrica, of course, is used by amateur astronomers and nowadays professionals as well. The following talk after mine by Shenzhou Chui is going to be on the IVOA, which is the Virtual Observatory Alliance. And in India itself and other places, I know a couple of examples where people not just use tools online, but then have used the planetarium domes. And I think that's something which is very interesting. And that's something we need to work on a bit more. For example, Dr. Ratnashri, she had put in the entire TGSS, TAFR, GMRT Sky Survey in the Delhi Planetarium. And I know that people had also put in the LOFAR sky surveys in the Amsterdam planetarium and so on. Right? There are other important or well-known projects I want to just mention, just for completeness, because I think some of these might be new to you, some of them might not be. Some of the ones I know of at least are the Worldwide Telescope from Microsoft, which then became an open source project, Exoplanet A, the Pulsar Search Collaboratory from Green Bank, ESA Sky, the European Space Agency project, LAMOST in China, and so on. Right. So all of these all of these are built on some large data set with some tools and visualization and guides, etc., which are then accessible to school students in particular. So that's why I wanted to mention them specifically. And lastly, since I started off being an amateur astronomer in school before I became what I am now, I also wanted to mention that big data in some sense, or at least data in some sense, has also been created by amateur astronomers for decades, if not centuries. And three prominent ones are, of course, the occultation timing groups, the AFSO, the variable star observing people, as well as the International Meteor Organization. There are many, many more, but these three are classic examples of how amateur astronomers and students and enthusiasts create data in turn, which goes into large databases, especially AFSO, for example, right? And that's a very interesting way of looking at what big data is and who creates it and who consumes it. And lastly, I want to mention this. I think all the Indians in the audience will know it. Chandrayaan 3 landed successfully on the moon. All of you must know about it. But Chandrayaan 2 crashed. It could not land. You could not make a soft landing. And after it crashed, people are trying to figure out where the crash site was. And there was some software engineer in Tamil Nadu in India who just spent hours and hours and hours out of his own interest just combing over LRO data of the moon, and then he was the first to find out the crash site, right? And then ISRO then got onto the act, and then NASA later got onto the act as well. And this is in some sense, it's again big data, but not used in a very classroom setting in a very structured, guided way. But if you put out data like this in public, people will find interesting ways of using it. And I thought this was a very particularly fascinating way in which somebody with no affiliation to anything astronomical just spent hours and hours on publicly available data to find something which is very, very important. So these are the kind of examples which will help us go ahead beyond just citizen science, I think, in outreach and education. I want to mention a few projects in India and some in South Africa as well before I move on to raising some questions which are in my mind. One of them, again, to go beyond citizen science, is a kind of a different citizen science project led by Sudhanshu Barve. I think many of you know him. He was at the SAIO for many years, and now he's at my institute, called the Million Galaxy Project. And that is a citizen science project, of course, but then it's built with a lot more added on, where students not just recognize patterns, but then they also learn more about galaxies, they learn what they're doing, they learn more about the larger astronomical context in which they're doing pattern recognition. I think that's something which I find is interesting. Some people might know RAD at Home, led by another person in Bombay here, called Anand Hota. It is a citizen science project again, using GMRT data. Again, it's not much about pattern recognition. People who join in are taught to go beyond that, to understand what they're doing, to kind of figure out what it is they're trying to piece together. And in fact, these have then led to discoveries, as well as the group members applying for additional observing time on GMRT, and led to even papers being published. So that's a very different, other kind of model. Right? And third thing, which of course I think is, people in Africa know very well about, is NASE. NASE is very common in many countries in Africa, Network for Astronomy School Education, and they've been doing wonderful work as well. So we heard from Bonita about Dara Big Data. It is an amazingly successful program. So I was wondering, can Dara Big Data, especially in terms of hackathons, have a school education component as well? And that's something, for all of us to kind of think about. There was something proposed. There was something called the Data to Dome, which was proposed some few years ago by the International Planetarium Society. Data to Dome basically is a project where they want to bring in big data and make it amenable to be broadcast onto the planetarium domes, and then do things with them in terms of visualization, identifying things, and so on and so forth. And that's something I think we should, both the APA, which is very, very active, as well as Indian Planetaria, can kind of work together, hopefully, and try and get more into this. A larger framework in which all of this sits in is, of course, the working group under IAU B2, Division B2, Commission C2. I'm not exactly sure about the hierarchy. It's called DAEPO, Data Driven Astronomy Education and Public Outreach. And one of the people leading this is the next speaker after me. So I'm sure he will mention this again. So this is the larger framework, which tries to bring together people working on big data and outreach and education from across the world. And that's something to look into. Okay. So these are some of the examples I know which are international as well as India specific or South Africa or Africa specific. So having kind of looked at all of this, what does big data mean in the EDO context? Right? In astronomy research context is very clear. Big data means petabytes or exabytes. So anything which is less than 100 terabytes, you scoff at, right? And that's just what it means in research. But then in education and development and outreach, I think we should go a bit beyond just the size of the data set. The number of people engaged, I think, is important. Big can mean immensity in various contexts in terms of number of people engaged, the scale of the region. If you're talking of 2 provinces versus 10 countries versus an entire continent, the diversity of people you're talking to. You could have a program which includes really elite schools as well as schools in rural areas, and then bringing them all together into one program which uses data is not easy to conceptualize, and so on and so forth, right? So, for example, for many years, people have been doing this measuring the Earth's circumference experiment by Eratosthenes, I can never get his name right, with 200 to 300 schools across India. That to me is a big data project. Now, it doesn't use data, but it creates data. But for me, it's a big data project. Measuring eclipse times across Africa would be a big data project, right? And again, what you mean by big will have to be redefined. If you're looking in areas which have less internet access or more rural, and that's something I think a couple of questions were asked in this context for the previous speakers as well, right? So this whole idea of big, I think one has to kind of revisit in the context of outreach, and it's not really clear to me that there's one clear answer, and it gets more complicated by the fact that the diversity, there's a huge diversity or difference in terms of access and as opposed to what you have in research. So can big data, so if you just take big data project and take it to a school, can it overwhelm a student? I think it can. And that one has to keep that in mind. More of something is not always better. Giving them a terabyte of data is not going to help them understand science any better than if you give them a megabyte of data. Can it exclude people? It very well can. Obvious example, of course, is low internet access, but then in so many other ways too, in terms of disabilities and so on and so forth. Can it be biased towards certain skills? Yes. So somebody knows programming already or is familiar with computers would get onto it much faster. And the tools and the projects you devise on data are done with these people in mind, right? We rarely devise projects using data which are meant for people who do not know programming much or something. So it just automatically biased towards people with certain skills, and that kind of is a positive feedback loop which goes on. Does it democratize science? I think it can. I think big data has a huge potential to democratize science if done properly. And if it takes into account the 3 points I mentioned before, and I think that's very important for us. The big advantage of having big data in outreach would be for democratizing science, in my opinion. But then it's not useful without the following: good tools to access and visualize data. It's obvious, one would hope, but then many projects I know that is not done, and then the project falls apart. Platforms that cater to differing access of various sorts, including language, like Bonita had mentioned before. Relating what you're doing to what is being taught in schools. You learn something very basic in school, and then you are exposed to something very fancy. It doesn't make any sense to students at all. You have to have a graded way of using the data. SDSS again is a very good example where they say you do this for class. They divide them into grades, saying easy, more, less easy, harder, difficult, and you go step by step. You engage in the science behind the data. For example, Sudhanshu Barve's Million Galaxy project, which I mentioned before, is one of the citizen science projects which goes beyond just using people to recognize structures, right? You engage the people, the science behind. Just don't look at data just as numbers to plot, but look at the science, use the data to talk about the science and apply to daily experiences. For example, there's so many. I have some colleagues in other institutes in India who use big data for citizen science projects for counting birds or things like that, right? Or to even record potholes in the road or where people litter and things like that. So big data is not just about exotic or fancy science. Big data is also about your daily experience. I think that needs to be brought in for people to relate to it better, right? So what are the advantages of using big data in schools? I think it gives them a lot of experience with hands-on data, and that's something we know all schools in all countries lack pretty much. It exposes them to programming. I think like the the talk on Codex earlier today. It also, I think, what is often not emphasized enough is that it also exposes them to statistics literacy. And if you look at the increasing prevalence of pseudoscience or and so on, a lot of this is based on illiteracy of statistics. Right? I base my belief on one data point because somebody told me something and so on. And I think looking at data, I think statistics literacy, knowing scientific method, critical thinking should be built into the way the students use the tools in the big data, right? And astronomy for development, of course, the integral part of all of this. And lastly, awareness of the scale of the universe and our place in it. A colleague of mine, I think some of the people there from India know him well, Vivek Montero. He started a project called Cognic Zoom, where he has hands-on experiments and demonstrations in a large space to help us visualize, to help us understand large numbers. We have large numbers in our life, not just as scientists, in terms of corruption or budget deficit, and we don't understand what a million or a billion or a trillion is. And I think the big data is a good way for us to teach students how to conceptualize large numbers, how to conceptualize the scale of the universe, but also things in our daily life, right? But needs to go much beyond pattern recognition, like I said, to not lose the science within the data. And I'll mention the REST program a bit later. And what follows after that? Do they just play around data, make a program, make a plot, and then that's it? What happens after that is something one has to kind of look at a bit more carefully. Gamification of data, sonification, etc., have all been done before by many people, and I think that's a fantastic way to go, and that's something one needs to kind of put some more emphasis on. Right. So what are the possible projects which I would like to see, or I think people are talking about already in India and maybe elsewhere too, or is open to collaboration between global South countries, especially like BRICS, right? There are a lot of models and tools which are available for for the global North, but there are very few of them made for low iterate environments. Sorry for the spelling mistake. In general, for example, can you do something mobile phones? Can you do something where I download the data and look at it later? So a lot of thought needs to be put into the technical difficulties, reconfiguring tools for low internet environments. India now has a lot of space data, and our space agencies are putting them all online, which is a new development compared to before. And ISRO, our space agency, has actually built some tools around the Chandrayaan, the moon lander data. But that's something one needs to, and there's some talk of making that a bit more open, of kind of applying that to other space mission data from ISRO and so on. So that's something which I know, which I'm interested in. There's a whole concept of bringing the observatory into the classroom. Can you especially if you have access to telescopes which are 12 hours away or 180 degrees away in longitude, then can you observe the night sky 180 degrees away from a school, from inside a school classroom? Those kind of things have been done before in a very, very few examples, but I think those kind of things should be scaled up. So in institutes like mine, which are basically research based, most of the programs are focused on college students, and therefore we started something called research experience for school students, where we made them do hands-on data, plot things on graph paper, measure things by hand, which was completely different from what they're exposed to, because they already all have laptops. And what we want to do is to kind of continue this, but build on this. Say, okay, now you do something by hand, and then you move on to something which is a bit more computer-based and so on. There is a project by the government of India here to build something called TechDome, which is an incredibly fancy data visualization pavilion, and that's something we are trying to see if we can put astronomy into it. And of course, SK and SST is something India and South Africa others have common. I just want to mention one thing. The world's first commercial LED dome planetarium is being built by us in a city called Mysore near Bangalore. LED dome planetarium basically means there's no projector at all. The screen is made of LEDs and it's 8K resolution, and the LEDs are controlled by the computer directly. And this is fantastic, of course, for the quality of visualization. Think of it's similar to the fancy dome which has come up in Las Vegas recently, which I'm sure all of you know about, which projects things inside and outside. This, of course, will be only inside, and it'll be done by the end of next year. But the idea behind this LED dome planetarium also is because it is completely controlled by the computer, to use it as a training center for data analysis, not just for astronomy, but also for science in general. And that's something, we invite, and I think and we are building it in Mysore, and I would like to invite all of you here to kind of talk to me about it later, and we can work on projects for this, and which we can then adapt to other planetaria as well. Lastly, I want to end with saying, so can we kind of look at the education, development, and outreach community, which is students, educators, communicators, etc., not just as consumers of big data, but also as creators of big data. So with that, I'll stop. Thank you.